All right, babies, in this video, we're going to talk about function characteristics and notation. So if you will look at the bottom of page 1 of your notes, that's where we're going to get started. And I'm just going to briefly go through these with you, and then I'm going to illustrate it on an example of a parent function. So some of the information we observe from our graphs, we've got domain, range, continuous, discontinuous, increasing, decreasing, and constant. Of course, I don't need to read all of those to you, but I do want to illustrate how they work in a particular function so that you will understand how to apply them to other parent functions. So I'm just going to look at page 2 of your notes, and I'm just going to choose a parent function that everyone is very comfortable with. I'm just going to choose the quadratic function. So, of course, we are going to write the name right here. And I know you've got all of these for each of the parent functions. I'm just using the quadratic function to illustrate the characteristics of a function. So I just want to write my equation here. And just to remind you, this is in function notation. Remember that when we have a function, we can write the y as a function of x because that's what it is. It responds to x, and that's how we know it's a function. So, well, of course, y always responds to x, but anyway, so if we've got a table of values here, remember that if I've got f of x here, then that's the same thing as having x squared right there. So when I choose a value and square it, that's how I get my y value. So I'm just going to fill this in with a couple of values here, and we're going to graph them. And of course, you could go on with this. If you chose 3 for x, you would have 9, because when it's squared, it's 9. So we've got our parabola here. I did not do a great job, but that's okay. It should have gone all the way down here. Yeah. Anyway, all right, so our characteristics of our behavior and behavior of our graph. So we've got our x and y intercepts are both 0, 0. Because it crosses the x-axis at 0, 0 and the y-axis at 0, 0. The domain, remember your domain are all of your x values. So remember, I'm going to get another color here. Remember that your x-axis is right here. All your positive values are over here and your negative values are over here. So since this extends up in the positive direction pretty much forever, it will eventually extend out in this direction. So for domain, we've got all negative values and all positive values because it does the same thing on the negative side. Okay, the range, notice that with the range, this is the y right here. Your range are your y values. And since the graph only lives above the x-axis, we're only concerned with the positive values for the range. So the range is going to be 0 to positive infinity. And notice that I'm using a bracket here at 0. That's because it includes 0. All right, so as we move through here, extrema. Values that are extreme are the highest and lowest values that the graph reaches. Well, since we've got arrows at the end of our graph, that means it extends forever in the positive direction, so we don't have a maximum. All right, that we're going to call DNE does not exist. And then for the minimum, it of course has a minimum at 0, 0. All right, now we're going to talk about continuous or discontinuous. Well, the way to think about this is if it's continuous, that means you can draw it without picking up your pencil. Well, were we able to do that? We were. So this particular function is continuous. Are all of your functions continuous? No. That's why I gave you the parent function video so you can see all of the characteristics of each of the parent functions. Okay, increasing, decreasing, or constant. Well, if a graph is increasing, that means it's doing this from left to right or this from left to right, some kind of action where it changes course along the x-axis. All right, so as you move to the right, if it's going up or continuing to go out, then we're going to be increasing like that. But if it's decreasing as we move from left to right, it should be doing something like that. So it should be decreasing in some way. Constant means it never changes. It just goes straight the whole way. So as you can see from the parabola, we are both decreasing and increasing. So it's doing both of those things. All right, even and odd and neither, that has to do with symmetry. Notice that my parabola is the same on this side and this side. So that means it's even. That means it's got symmetry over the y-axis. These notes are messy. Sorry, kids. And then, of course, we're going to talk about end behavior. What's end behavior, Miss Griggs? Well, end behavior occurs right up here. If you'll look at your graph again, end behavior does this. So how do we talk about it? Well, we talk about end behavior as how y responds to what x is doing. So as you can see, x is extending up forever in the positive direction. So x is approaching positive infinity. And how is y responding to that? Well, y is right here. It's going up. So it's doing the same thing. Now, as x approaches negative infinity, which is this way on our graph, negative infinity, y now is approaching, it's still approaching positive infinity because it's still going up, but the x is going to the left, which is its negative direction. Okay, so hopefully that helps a little bit with understanding functions and their characteristics. So I'm hoping that that kind of clears that up for you. Before we move on, I just want to briefly touch on notation because a lot of you have probably forgotten this from algebra. If we're dealing with set notation, it's a set of numbers like this, and we read this as a set of all the x values such that, or so that, x would, let's say, be greater than or equal to -3, less than 1. And I'm just making this up, okay? So that would be a set notation. Well, how would that same thing look in interval notation? It would look like this. Oh, I can't write all of a sudden. Okay, so -3 because it's included. See, that means included. If it's less than or greater than or equal to. So that's what the bracket means. And then, of course, it says it's x is less than 1, so it would look just like that. So if you can visualize that on the number line, it really helps to understand it a little bit better. So let's just look at that. So I'm going to have a closed circle at -3, an open circle at 1, and all the values in between because it says x is less than, see, x is less than 1. So that's less than 1 right here, and x is greater than or equal to 3, -3. That's why I have a closed circle. Anyway, enjoy!